Hey guys, in today's video I'm going to talk about the data type any. So the data type any can be declared as an input and can be used if you don't know what kind of variable you're going to pass to your function block or method. You can use the any type as an input as a generic type. So let's say you don't know it's going to be an integer that's going to pass through your input, or it's going to be a double integer. You can just put any as an input and pass them both. So how does the any data type work? After the code is compiled, the any data type is replaced with this structure. So the structure, it's pretty simple. It has a system type class, it has a pValue, pointer to byte, and double integer size, which is double integer. What does this mean? So the type class tells us what kind of variable was passed. So if I pass an integer to my function or function block or method, I'm going to receive type class int. If I pass a double integer, I'm going to receive type class double integer. If it's a string, you're going to receive a string. The eSize tells us how many bytes are in our data type. So let's say if we pass an integer, again, you're going to receive 2 bytes because the integer has 2 bytes in CODESYS. If you pass a double integer, you're going to receive 4 because we have 4 bytes. If we pass, let's say, string, normal string with 80 bytes, we're going to receive 81 because of the 0 termination after the string. So the 80 bytes you can use to store characters, and the 0 termination you cannot use, but it's there. So we're going to receive 81 bytes. The pValue is a pointer to byte, so to which element of the value, and it always points to the first byte of the variable that you have passed. So it's pretty simple. And I'm going to create one function block that converts an integer values, let's say a double integer, unsigned integer, and integer, into a real value with decimal point. I'm going to create a method that can be used in this function block for the conversion, and I'm gonna show you how to do that. If you don't understand something, it's okay. You can ask questions and I'm gonna answer them. So let me start with creating a new function block. The function block is a class or blueprint of our objects. So let's say a name and convert to real. That's my function block. So I want this function block to be instructor text, and for the function block I'm gonna declare an input of any. So you can declare it as an any. That means you can pass every single variable, string, it doesn't matter, byte or something like this. But if you know you're gonna pass only integers, you can declare it like this, any underscore int. That means that in compile time, if you have a string as an input, you're gonna receive an error. If you have the any type, you're not gonna receive anything. Because I want to use integers in this particular case, I'm gonna declare it as any type int. But as I said, you can declare it as an integer. So that's the first step. The second step is we want to have some, let's say, many types of integers, integer values. That means an integer, and double integer, and unsigned integer. Of course, there are a little bit more, but for this video I'm going to use only those 3 to show you how to use any variable. So I want to have a buffer, an integer, which is from type int, I want to have a buffer which is from type double int. And I want to have buffer which will be unsigned double integer. What I need in this particular case, because I receive only the value of the passed variable as a pointer, I need a pointer. Let's name it destination from type pointer to byte, which gonna point to one of those variables, and we're gonna take the value of the any, and through this pointer we're gonna pass it to the buffers. How are we gonna do that? As I said, we know our any, so our int in any has a type class. So I'm gonna create a case of the type class. First, we need to use system type class, and here I can check if the system type class is an integer. Let's say system type class int. I can create one for system type class type double int, and one for system type class type unsigned int. So if you pass a variable, let's say integer, double integer, or unsigned double integer, we gonna jump into this case. Else we are not gonna do anything. We can generate error or something like that, but that's not so important right now. So the second step is, we know that because of our any type class, we know that we have an integer. So we need our pointer to point to an integer variable, and that's this local variable. With address, we're gonna point to this variable. If we we need the buffer, of course, address and then the buffer. So now our pointer is gonna point to the integer variable, because we have the case of integer. If we have the case of a double integer, we're gonna point, of course, to the double integer variable, to this one. If we have unsigned double integer, we're gonna point to the unsigned double int. We need to do that because of the type difference. When, let's say, we have the int and unsigned the int, the main difference is this, that the 31-bit is the tell us of the if the variable is positive or negative. So if we have -1 here and point to this buffer, but we want to pass the value to unsigned integer, we're gonna receive some numbers that are not correct. That's why we always need to point to the correct data type. So after we have created this, I'm gonna create a method that that converts the bytes or copy the bytes of the passed variable into the buffer throughout the pointers. So let me create one method. Let's name it copy. We can return some data type, and this will be a private method that is going to be used only here. for this case here, I'm gonna use the this pointer. So let me do this for let me create one variable here. This is just a normal counter. Which is gonna be from type int. Equals 0 to, and now I'm gonna use the this pointer. The this pointer tells us only makes a difference between the local method variables and master class variables. So with this, I'm just gonna point to our any, and I'm gonna use the diSize -1, because if we have 4, so 0 is 1, 1 is 1, 2 is 2, 0 is 1, 1 is 2, 2 is 3, and 3 is 4. So if we receive 4, we don't want to go over the over the limit. So now what we want to do, we're gonna use the this pointer again. We're gonna set our buffer and the count will be equal to the this any pointer value pValue the count. So basically what we do here, it just we copy the bytes, nothing else. We just copy the bytes from the value that we pass through into the pointer that we've created. Now I'm gonna check what the problem is. Oh yeah, I see it now. Perfect. So that only this method only copies the bytes from our any type to our destination, and our destination is eBuffer, double integer buffer, or unsigned double integer buffer. It depends in which case we are jumping. So if I do, I can just call mcopy as a method, and there we have it. So every time now when we receive let's say an integer variable, we're gonna jump in this case, and our pointer is gonna point to the first byte of an integer variable. Then we're gonna call the method, and this method is just gonna use just gonna copy the bytes from the variable to this one. So afterwards, let's say I'm gonna because I want to have it as a real, let's say real buffer, and as an output I'm gonna set the real variable converted as real. Now I'm gonna say real buffer is to real, convert to real, and I'm gonna take the integer variable. I'm gonna do exactly the same for the other two types. Real buffer, convert the double integer, and real buffer, convert the unsigned double integer. Perfect. Now if I want to have a decimal point, I'm gonna need a second input because I need to know the decimal point size. In this case, I'm gonna create enumeration, and I'm gonna call this enumeration decimal point. Now I'm gonna delete all the pragmas. I'm not gonna talk about those today, and let's say no decimal point will be the first one, which is gonna be equal 1. Then I'm gonna have 10. It's gonna be 10, 100. It's gonna be equal to 100, and let's say 100 hundreds, and let's gonna say 1000. Thousands gonna be equal to 1000. That's my enumeration, and this enumeration, it's gonna be my divider. So I'm gonna have the enumeration as an input as well. Let's say in decimal point. This is gonna be from type EDP. And now, just to return a value, I'm gonna set the convert, the output to be equal to my real value, my real buffer, divided through the input EDP. So that's basically the whole function block. Of course, here you can have some more integer types, but as I said, I just want to show you how this works. So perfect. Now let's create the function block. First, I'm gonna declare the function block, convert to, let's say, leave it like this, convert. So perfect. Now I'm gonna have a result, which is gonna be from type real. Now I'm gonna have pValue, which is from type integer, double integer value, and unsigned integer value. Perfect. So let me, not this one, sorry. Perfect. So as an any variable, first I'm gonna pass the integer variable just to show you. As a dp, and let me declare one. dp will be equal ADP decimal point and the result, of course. Now let's log in and check our function block. Now I'm gonna say -1 and force this value. As a result, we receive -1. If I have a dp, so decimal point, let's say tenths, -0.1. If I have, let's say, thousandths, -0.001. How does this work? Let me set a breakpoint. A breakpoint you can set with F9. And with F8, you can jump into your function block, and etc. So we jump. Our any, as I said, has pValue the E, size, and type class. As you can see, our actual value is type integer. So our case, the first case, is system type integer. So we're gonna jump into this case. Now our pointer points to the our buffer integer variable. So this buffer is only needed to store the value. So our pointer needs to point to something, and now it points to the integer variable. Now we have, in this row, we receive an address for our pointer. When we open the method copy, you can see that the size is 2 bytes. So our pointer that we declared points to the first byte of an integer variable, and the any pointer points to the first byte of our E value. Now we just copy the bytes, so the first byte is going to be copied to the destination, to our destination, and then the second byte, and that's it. We just move the bytes or copy the bytes and return the value. That's basically how this function block works. Let me put the integer variable so we have a little bit more. In the method we do basically the same, absolutely the same thing. So let's enter some number, and as I said, we can put some decimal point, let's say tenths. As you can see, our result, we have the tenths. The conversion does basically exactly the same thing. We jump into the int case. Our pointer points now to the int variable. So we store our pointer points to 4 bytes. And with our method, we go through every single byte and copy it into our system. So afterwards, we receive the value which we gave as an output. So that's basically how you can create a generic function to convert integer values into real values. Now I want to show you a CODESYS function, which is found in the help. It's very simple function. I'm just gonna copy it and create one function. Compare. Let's oh no, that's not the PU. Compare. And this is going to be a function, and we're going to return a bool variable if they're equal, the two values are equal. So let me copy this. I don't need this one, and basically I don't need this one. I don't know why CODESYS put false at the beginning, because every time the function is called, the value of the function return type is set to 0. So let me delete this one and type the name. So how does this function work? It's pretty simple. You have two variables as an input. So first of all, it's going to be compared if the type class is equal. So let's say if you pass an integer and double integer, the function will return false and you're just gonna jump out. If you have an integer, everything is okay, so you're gonna go to the size. The size, of course, of integer and integers is the same, but let's say if you compare two strings, the type class will be string, everything is okay, so you're gonna pass the first if. But in the second if you pass, let's say, a string from 1 byte and a normal string from 80 bytes, you're gonna jump out because they're not equal. So let's say you have two strings with 80 bytes as well. Afterwards, the bytes are compared. If the value of every byte in the first variable is equal to the value of every byte in the second value, you are not gonna jump out and your compare will be true. We can test this function as well. Let me declare, let's say, string 1 as a normal string and string 2 as a string of 1. So let's call this function fCompare. We need the two strings or any other variable. As I said, you can put real, you can put int, you can put everything. So yeah, let's check this function with breakpoint again. So the type class is string, that's okay, and we can go further, but the size is different. As you can see, we have 81 for our 80 byte string and 2 for our 1 byte string. So we're gonna return, and the function will return the value false. They are not equal. Both are not equal. So okay, let me declare the string as a normal string. I'm gonna clean and I'm gonna log in again. So now, as you can see, they are equal as well, and every single byte will be compared. So let me make a breakpoint here. As you can see, now we're gonna return a true value because every single byte is equal to every single byte of string 1 is equal to string 2. If we type something, let's say A, that will change right away. Now, if we go into the function, you can see the size is equal again, but in the first byte of the first any variable, we have 65, that's A in ASCII code, and 0 in the second. So they are different, and we're gonna return with false. So this is a generic compare function from CODESYS, which you can use for every single type to compare if two variables are equal. So guys, that's basically everything about the any variable and how to use it. Of course, if you have any questions, please don't hesitate to contact me and I'm gonna try to answer them. Thank you for watching and have a good one.